Now we are going to do experiment number 2 for General Chemistry 101 lab. The title of this lab is a volume lab. The volume lab basically introduces students to the different apparatus that is used to measure the volumes of liquids. At the same time, when you are using such equipment, you get to learn how to use them on the online simulation labs, as well as how to read the various equipment that is there, how you can recognize which is the most sensitive equipment for measurement when you compare it with a graduated cylinder, a beaker, burette, and pipette that is there. And so, but with this brief introduction and with the understanding that now you know how to write a lab report by following the template, I'm going to demonstrate this particular experiment for you by sharing my screen so that you will understand how to do the experiment. And please note that I'm not going to go through the introduction. You all can read it, but generally when the volume lab measurements, when they are precise measurements of liquids are liquid, then we use different glassware such as burettes, pipettes, volumetric flasks, and graduated cylinders are used. Then some of them are very accurate and others are not so accurate, and these beakers and various items are used for mixing, separating, etc., for heating the liquids, cooling the liquids, and so on. So with that, if you can go through this introduction and write the introduction by yourself, I'm just going to demonstrate a few sets, a few techniques that are there. Again, these techniques must be learned in order to be accurate in your data. Don't try to practice them before you just jump into the experiment and then start doing it. Now, first is the graduated cylinder and how you use it. So go to the equipment menu, get a graduated cylinder that is 100 ml. There you have it. If you right click on it, then you want to add water. So whatever the volume of water they have asked, you can add it. And please note, don't copy what I've done, amount I have added. Then you can, you can see that the markings are very, very close and it's difficult. In that case, you just say that you show the meniscus, and then you can clearly read the meniscus with the eye. And so you can get an accurate result of your value that is there. And then again, they say you can obtain 100 ml beaker. So this is the first part. Make sure you take the picture, post it in your lab report. Then you get another 100 ml beaker. That's the next experiment. And then they say that you transfer. So get the beaker here, and you can remove the meniscus. Remove the meniscus. Then you can use the pour decant and adjust it above so that the now you're finished with the cylinder. Then the volume of liquid is transferred. Read it how much it is. Then it says you get an Erlenmeyer flask. Go to the equipment, get an Erlenmeyer flask. 100 ml, whatever the volume is, you get 100 ml. And this is called as the Erlenmeyer flask because it looks like a cone. And then, so now, again, you take the picture. Then what you do is you pour and decant, so to get it above, and transfer the liquid into the Erlenmeyer flask. And so now you can see that. And so this is how you pour, decant, and the names of the different flasks and containers that you have. And as you pour it in, you can read make sure you can record the reading so that you can find out which one is the most accurate amongst that. Next, we're going to do a simple titration. And so you go to get a burette, a 50 ml burette. As soon as you get the 50 ml burette, a titration dialog box appears. Click on the burette and fill it up with water to the maximum, which is 50 mLs. And so now you have a burette that is filled with 50 mLs of liquid. But please note that the burette starts reading from the top to the bottom. So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so from 0, it comes down. So don't start writing from 50 and go up. No. But as it drains out, you will see that the color changes. Right now, it's very white. It will change, and therefore you know that the burette is like draining out the solution. In order to drain out the solution, again, if you want to see the meniscus, you just say show the meniscus, and there it will show you the meniscus, and so you can read that very well. Then the burette actually reads 0.1, a graduation, and so this is only visible with the meniscus shown. You can see that. All right. And then what it says is follow the instructions. They don't want you to get. Yeah. Okay, I got a 250 ml beaker. So let's delete that. You can keep it, but if you want, you can go and change the volume of the beaker to 100. No, we don't want a beaker. We want a Erlenmeyer flask, 100 ml Erlenmeyer flask. So get it below. And then so now they want you to drain 1 ml. So click over here and slowly move it. As soon as the meniscus comes to 1, stop it. And so now you can see that you have drained 1 ml into the flask. You can note, so the starting volume was 0.00, and now the end volume is 1.00, and that's how you record it. Then now with the 1 volume, now what they want you to do is you drain out about 25 mLs or so. I'm not going to drain out that, but again, I'm going to move it. So this is the initial end value. So now I'm going to again go ahead and start draining it. And you can keep the meniscus so you can see how much you're draining. And it's worth keeping it so that you don't have to repeat the experiment again and again. So as soon as it comes. So there, I just drained out some volume. You can see the volume, and that's gone inside the Erlenmeyer flask. And you can use this to control and learn how to now control the burette and read the volume. So at this stage, the volume will be now recording from 1 to 10. So it's 11. You started at 1. So the volume extracted is 10 mLs. And make sure that you record all these correctly. Now we go to the last bit that is there, how to use a pipette. A pipette is an instrument which has a bulb in the middle of it. It's a narrow tube with a bulb in the center. The bulb records the volume that is can be withdrawn from any given sample. And there is a marking near the neck. And so you go to the equipment. So that's finishes of the, so we've done first the water graduated cylinder, beakers, Erlenmeyer flask, burette, draining of the burette, recording the mass. And now we go to the pipette and we get a 35 ml pipette. We get it over here and keep it. And then they also tell you from the pipette, get a 100 ml beaker. So let's go and get a 100 ml graduated cylinder, a 100 ml graduated cylinder. We'll keep it there. Obtain that extra. Yeah. Okay, and then we want a 100 ml beaker. So now you can see that I have all the equipment for the last part set in order. So that's it. So now I'm going to go to the 100 ml beaker and put in there that I want 100 ml of water in it. And then I'm going to say extract. Okay, so now we extract. And you can see that the volume is extracting. So then now the liquid has been extracted. So now you saw that I placed it and said extract the liquid. As the liquid is being extracted, the thumb is opened, as you saw before. Now, once the liquid reaches the line mark, which you can see over here, right on the top, just below the pinky finger, then you place the pipette on above the graduated cylinder. Click on the pipette. Click on the pipette and say release. There. Click on it and say release the liquid, and it is going inside the liquid. Whatever amount is extracted, it will release it into the graduated cylinder. Once that is done, you record the volume released into the graduated cylinder. A graduated cylinder and record its volume. So now I'm just going to place each of these experiments that I have completed in a sequential manner so that I know what I have done. And then I'm going to put the burette with its meniscus. And then I'm going to put the Erlenmeyer flask below. Then we have done that. And then we finish this, and then leave some space in between, and then put this in there to release the liquid. And then now we are going to prepare a solution. And now first we have to get 100 ml volumetric flask. A volumetric flask is like a round bottom flask, a flat bottom round flask. Which has again markings on it. So here it is. You can see that it's got a marking over here. And that's when the liquid comes up to this point that we know it is 100 ml. Of course, it's got a stopper and everything else so that when we shake it, the liquid will not come out. So then we are going to get a balance. You can click on it, put the chemicals on it. And so here is the chemical dialog box. I want to put sodium chloride. I'm just going to read the procedure, what it says, how much sodium chloride, you put it inside it, and then you, okay, now, okay, now you get water, and so now partially you can fill it up. So we put 50 mLs, and then let's see if it will, yeah, you can then use the stirrer to mix it, as I showed you. And so once the salt is mixed and the stirrer goes back, then you carefully add the water and you fill up the flask. Now you go to the water menu. Okay. So that's how you make the salt solution. So now this is how it is done on the simulation lab. But if you were to do it the same thing in the lab, then we would add the water, stopper the volumetric flask and shake it twice, thrice, up and down, so that all the solution is mixed and it is uniform. And with that, you can complete the observation tables, complete what the question is asked. What is the molarity of the salt solution? Molarity of the molarity of any solution is defined as the strength of the solution, and it is given as moles of the solute divided by the volume in liters. In order to calculate the mole of the solute, you get whatever mass of the solute you have taken divided by the molar mass of the compound. Then that ratio is called as the mole of the solute. And then all the information that is needed is provided. And then you can get the answers. After that, you complete everything. Make sure you have copied all the pictures, as I said. Complete the homework, save everything, and then submit it.